Hey, welcome back to Workplace 30. We're moving on to section 5.3, which is our last section of this chapter. You can start by reading Math on the Job on page 202 and answering the following questions. So number 1, divide the drawing of a honeycomb cell into 6 equal triangles. So if you draw your hexagon and just connect the vertices, you're going to get 6 equal triangles. Part 2, what are the internal angles of each of the triangles? Classify the triangles that are created. So let's start by finding the central angle. So the central angle are the angles that are all the way around the middle part. So what is the total all the way around the middle? Good, 360 would be your total all the way around. Then there's 6 equal triangles, so we're going to divide it by 6. So we get 60 degrees each. So each of these angles here is 60 degrees. Now we can also figure out these other angles, because what kind of triangles have been made? Okay, we're assuming equilateral, but we definitely know they're isosceles. So how could I figure out these two angles to prove that it is equilateral? 180 minus 60 is 120, divided by 2 because they're both the same. So good, then each of these angles are also 60 degrees. So we have actually made an equilateral triangle. Or a bunch of equilateral triangles, sorry. Good. Next, we're going to read Explore the Math on page 202 and write down the following definition. Just before you do, please pay attention to this chart. It's named the polygon. So these are a bunch of different polygons that we use all the time. Triangle is the first one, so tri means 3, quad means 4 sides, pent means 5 sides, hex means 6 sides, hept means 7 sides, oct means 8 sides, non is 9 sides, dec is 10, and dodecagon is 12 sides. Then there's other ones that don't really have names, like 11 and 13. So those you just use your number. So an 11 gon or a 13 gon. You could have a 25 gon, 1,000 gon, something like that. Okay. If you don't know the number of sides, you call it an n-gon. So n is just for any number of sides, you call it an n-gon. So go ahead then and read Explore the Math and check to make sure that your definition here is correct. Example 1 on page 203. Pete works for a tool-making company that supplies wrenches to the water utility company in Red Deer. Fire hydrants have regular pentagonal bolt heads, so it's a pentagon, which means 5 sides. Pete's company makes special wrenches to fit the bolts. Since a regular pentagon has no parallel sides, an ordinary wrench or pliers cannot grip it easily. So this is to avoid unauthorized tampering. What is the internal angle at each corner of the regular pentagon? Okay, so here I have the general shape that it is. So here they have that this angle, each of these angles, sorry, is 72 degrees. So they got that because 360 degrees is all the way around the center, because 360 degrees is a full circle, divided by 5, because each of those is equal parts, which is 72 degrees. Now we need to figure out each of these other angles, B. So since this side and this side are the same length given here, we know that we have an isosceles triangle. So to find the other corners, we'll go 180 minus 72 divided by 2 to get B, which is 54 degrees. So if B is 54, and this B is 54, that makes this B also 54, because all of these triangles are congruent. So what is the sum of the internal, what is the internal angle? So we want to know what this whole angle is. So we can find that by adding up those two values. So the whole B plus B is 54 plus 54, which is 108 degrees. Now we also want to find the sum of all of these internal angles. So we want to add each of these internal angles up. Since it's a regular pentagon, we know that they're all the same. So we want to go 108 degrees times by 5, because there's 5 of those angles. So the sum of the interior angles is 540 degrees. So here we're going to attempt a proof. We're going to prove that the sum of measures of the interior angles of any n-sided convex polygon can be expressed as 180 degrees times n minus 2, where n is the number of sides. So we're going to start by drawing an arbitrary polygon. So we're going to make something like this, but I'm going to just put dots to finish it off, because what that does is it does not mean this number of sides is set. Okay, so let's say that this is an, so that could be any number of sides. This would be our first vertex, our second, our third, our fourth, this would be like our fifth, and then there could be any number in between 5 and n. Okay. Next, what we're going to do is I'm going to connect some of these vertices to make triangles. Okay. Oh, sorry, I did that backwards. I wanted to go from this one. Okay, so now I've got a bunch of triangles. What do you know is the sum of the interior angles of any triangle? 180, good. So we know that each of these will add up to 180 degrees. So here we have 4 triangles of 180 degrees, and here how many actual vertices are there in this? How many points? Okay, right, in this proof there's actually n, okay, but here I did draw a 6-sided shape. Okay, so this is for the proof, this is for the example. So for the example, there are 6 vertices and 4 triangles made. Okay, and if each triangle is 180 degrees, that means I have 4 times 180 would give me the total interior angles. Okay, now another way of doing this is there's 2 less triangles than vertices. So I could also write, if n is my number of vertices, n minus 2 is my number of triangles. And each triangle is 180 degrees, so 180 times n minus 2 is your proof. So now this is the formula that we are going to be using. So how would you calculate the central angle of each equilateral triangle in a regular polygon? So if I would make each of these shapes into equilateral triangles with the little flower there being the center, how would you figure out each of these central angles? Good, so you take 360 and divide it by the number of central angles that you have. So here there's 4 central angles, so divided by 4, so each central angle would be 90 degrees. So in the next one, here we have 6 central angles, so we'll take 360 degrees and divide it by 6. So each central angle is 60. Try the last 2 on your own. You can check your answer on the board to make sure they're correct. So then you can go ahead and try the mental math. Here we have paradise pentagon, Sunnyside square, and equilateral state. So you know that the interior angle of a pentagon is 108, the square is 90, and the equilateral triangle is 60. You're trying to find this other angle. Try it on your own first, without a calculator. Then part B, all 4 sides are equal. So if we make these 2 sides here are equal, and we need to make another 2 sides here that are equal, what shape has been formed? A rhombus. Good, because a rhombus has all 4 sides that are equal, but it's not a square because this angle was not 90 degrees. So this angle is 102, which could not make it a square, so you have a rhombus. Okay, discuss the ideas. The sum of the interior angles of a polygon can be calculated using this formula, this one that we just proved. Use it to calculate the sum of interior angles of a triangle, a rectangle, a hexagon, and an octagon, which I'm not going to attempt to draw. Go ahead and check your answers with mine on the board. Then we're going to graph this. So on your graph, you're going to have n as your x-axis and the sum of the interior angles on the y-axis, make sure your x-axis is about 4 squares off of the bottom. And go ahead and graph this information just like we did in chapter 1. Alright, so once you've got it drawn, it should look something like this. And notice that this graph is linear. So when it's linear, we have an equation that is y equals mx plus b, where b is your y-intercept, which is right there. Y here is the sum in degrees, and x is actually your n value. So I could rewrite this as, just extend this, as the sum of angles equals your slope. Okay, let's look at your slope here. So we're going up by 180s and over by 1. So 180 over 1 is your slope. So about 180 degrees. X is your n. B, or your y-intercept, is minus 360. Okay. Now if I take out a 180, if I factor out 180 from this, I'm going to get my sum of interior angles equals 180 times n minus 2. Ta-da, there's your formula again. Alright, then let's look at these drawings, and they're increasing their number of sides. So the first one here has 4 sides, 6 sides, 8 sides, and 12 sides. What do you notice about the shape as the number of sides increases? It becomes more circular. Good, so it becomes more and more like a circle. 5. If you consider the circle to be a polygon with infinite number of sides, what would be the sum of the interior angles? So if you had n is infinity, if you had infinite number of sides, what would the sum of your interior angles be? Okay, so 180, n minus 2, so that's like times infinity. So you'd get a huge, large number, which would actually be very close to infinity, and that's your infinity symbol. So in other words, it would get very large. And last but not least, you have an assignment, page 207, number 1 to 7.